on notes. If you have your phone out, go ahead and put it away. Last semester, we proved something like this. You don't need to write this down. We proved triangles were congruent. We did a cutout activity. We had that yellow poster on the wall there. There's a lot of ways to prove triangles are congruent. They could share 3 sides exactly. They could share 2 congruent sides with an angle in the middle. They could share 2 congruent angles with a side. Let's see, there's 2 more. Angle, side, angle, and HL. That was last semester. We proved triangles were exactly the same. Something like this. So in other words, if I have 3, 4, 5, 3, 4, 5, they have 3 sides in common. They're definitely the exact same, or what we call congruent triangle. Today what we're going to do is prove triangles are similar. So if I want to prove triangle ABC is similar to triangle DEF, there are 3 ways to do that. And to prove similar, you're showing basically that a dilation has taken place. They're not exactly the same. They are proportionally bigger or smaller. So twice as big, 3 times as big, a half as big, something like that. Every side has to be proportionally bigger or smaller by the same amount. Remember, our angles, we've done this before, our angles should still remain the same size. Look at those angles. They share that angle, they share that angle, and they share this angle. The angles remain the same size. It's the sides that get bigger or smaller. So let's take a look at the 3 ways to do this. They're right there in your notes. Let's do the picture first. Let's go ahead and draw a big triangle and a proportionally smaller one. You can see the name of the theorem here, AA, angle similarity postulate. That means if AA, if they have 2 angles in common, they're definitely going to be similar. There's definitely a dilation. So let's just mark that with a single arc. Top angle, they share that one. And let's say they have another pair in common. Oh, that was kind of tricky. That's a picture of 2 triangles with 2 angles in common. That means there's definitely a dilation taking place, and they are going to be similar. For the next one, go ahead and draw your triangles again, and we'll mark them differently. This one is harder to show because the sides are not going to be the same number. They're going to be proportionally bigger or smaller. So let's start with a smaller triangle. Let's just label it 1, 2, 3. And let's label this one 3, 6, 9. Does it look like there's 3 sides that are proportionally bigger or smaller by the same amount? Remember, not adding, we are multiplying. So let's look from here to here, times 3. Here to here, times 3. Here to here, times 3. The way we show that is in a proportion. So we need to take 2 sides that correspond. Let's go with the smallest one. Let's go with 1. Smallest side here, 3. Take the next pair of sides that correspond. I'll go with the next biggest side. 2 corresponds with 6. And our largest side of this bottom triangle is 3. largest side of the top triangle, 9. If these are in fact equal, then they will be similar by side, side, side. I think we can do this without a calculator, but you can definitely use a calculator. 1/3 simplifies to 1/3. 2/6, that simplifies to 1/3. This 3/9 simplified to 1/3. Yes. If this happens, if all sides simplify to the same thing, then yes, the two triangles are similar. Let's draw the last one. Draw your original triangles again. You can tell by the name of this theorem what's going to happen. We're going to have two sides that are proportional, so kind of just this much work for the most part, and one angle. Notice the order. It's SAS. So the angle has to be in between the two sides. So let me pick two sides. Let's go with 1, 2, and 3, 6. Do you know which angle is in between the two sides? Can you tell? This one, right? That top one? Yeah. So let's mark the top angles congruent. The angles are already shown congruent. Let's make sure the sides match up. We know they will, but we have to show our work. So the smallest side 1 goes with the smaller side 3. That should equal the same fraction as the other pair of sides matched up, 2/6. You do want to make sure it does simplify. So these are the 3 ways to prove a dilation has taken place or the figures are similar. Let's look at example A. Is there something? Is there third angle? We can skip that third angle theorem that's there. Example A, determine whether the triangles are similar. If they are, write a similarity statement. A similarity statement is this. Whatever it is. So we'll write that if we think they are similar. So our choices are they share 2 angles. They have 3 sides that are proportional. I like that. Or they just have 2 sides that are proportional and an angle in the middle that's exactly the same. Do you have an idea which way we're going to go? Who has an idea which one we're going to pick? Yeah, we're going to try to go this route because there's no sides listed to put in a proportion. So I can see that this is 90 and this is 90. So let's write down angle Y and go to angle B, both 90. That's one angle. That's not enough. The other angles listed don't match. So do we assume these are not similar? Anybody see something else we could do before we just stop?
90 plus 53 and subtract it to see if we get 37.
Very good. All angles in a triangle add to 180. So let's see what's missing up there. 180 degrees minus 90 minus 53 is in fact 37. So I know angle Z is congruent to angle C. They're both 37. So are they similar? Yes. AA similarity. I would have to have all of this, not just AA. I have to show the two angles. I think we're going to save the similarity statement for another day since we're running a little short on time with that quiz we had. Flip to the back. We have a bunch of examples of two triangles. We want to know if they are similar. Let's look at this first one. You can already tell that the small triangle and the large triangle have a 44 in common. So let's call this, we don't want to call it angle R because there's a lot of angle R's. So let's put a little 1 and 2 in there. So we know angle 1 is congruent to angle 2. They're both 44 degrees. There's one angle in common. No other angles are listed. Anybody know what we're going to be able to do in this problem? Yes. So watch as I draw the small triangle. And as I draw the large triangle. You guys notice that they both have that exact same angle? Even though we don't know what number it is, they both have it. So it doesn't matter if it's 10 or 50 or whatever, they both share it. They're overlapping. Overlapping is called reflexive. We had that a lot last semester with sides. So you can write angle Q, congruent to angle Q, reflexive. If it overlaps, they both have it, reflexive. Are these triangles similar? Yes. A similarity. Any questions? Okay, let's look at B. I don't see any angles listed. I see 3 sides. So we are going to set up our 3 sides and see if they simplify to the same fraction or decimal. Where to start? It doesn't matter where you start. I always start with the smallest side and then go to the medium side and then go to the largest. So the smallest side of this first triangle is 16. The smallest side of the other triangle is 12. I go back to the first triangle and get the medium length side. So 20. Back to the second triangle, the medium side. Back to the first triangle, largest side. You can simplify it to the same fraction, or you can use a calculator and you may simplify it to the same decimal. Either one you want, go ahead. I got the same decimal every time. So that means all 3 sides are proportional. So we're going to say S, S, S. Similarity, which means yes, they are similar because 3 sides are proportional. Let's make a note at the top of your page. If you would turn it over, and at the top, let's write this. Angles, just like the top corner. Angles, when we're looking for those, they should be exactly the same, or what we call congruent. Sides, remember, they're not congruent. They're not the same length. Those are, we write it as a proportion. So we say they are proportional. Does this make sense? You need to use the right words. Angles are the same, congruent. Sides are proportional. They're not the same. They simplify to the same fraction. One more thing, triangles. The two triangles, the word we use are they are similar. It's this symbol. We're going to go ahead and keep taking notes until the bell rings, but I'll just say that you don't have homework. So let's keep working till the bell, but no homework. So flip it to the back. Let's look at letter C. I see two sides, and I do see the angle in the middle. So it's likely going to be this. But I have to check, because just because these sides are listed doesn't mean they're going to simplify to the same fraction. Most of the time they do, not always. So let's go ahead and write our proportion and see if it does work. Again, I'll pick the smaller side of the two, 24. Smaller side then is 18. Go back to the first one. We're not solving for anything. We're just putting all the numbers in and simplifying each. Happens to be 1.3 like the last one. It's not always going to be 1.3. Don't think it has to be. So there's my two sides. I have two sides proportional. I should write something about the angle, so that's pretty easy. Angle R congruent to angle N, both 90. And then I can say my final answer. If I were giving you homework tonight or any future homework or quiz, just this is not good enough. You have to show me which angles are exactly congruent and which sides are exactly proportional by showing your work. D's kind of tricky. Let's take a look at that one. D doesn't have any sides, so if it's going to be similar, it's going to be by angles. Do we remember what these angles are called? Vertical. Let's give them a 1 and a 2. Otherwise, we have to use 3 letters. Do not call it angle F. There's a lot of angle F's. You have to use 3 letters or call it something different. Do we remember what these arrows mean? Parallel. I'm going to extend it. You don't have a highlighter like I do, but you have a pencil you can highlight. And then I'm going to pick either transversal. Let's say I want to go with this one. Look at these angles made up here. I don't care about all 4 of these, but I do care about this one because that's the only one in the triangles. And down here, I care about this one. Do you remember what those are called? Angle E and angle J. They're on the inside and they're on alternating sides. Those are called alternate interior angles. I probably should put a double arc because I've already used a single arc. So are these triangles similar? Yes. I should put A similarity. We won't have time to do the last one, but we did one like that. It has 3 sides, so you would set up all 3 sides in your proportion.